Okay, so let's get started. We're going to cover section 8.3 today, which is partial fraction decomposition. So partial fraction decomposition is going to be one of our applications for solving systems of equations. We may be able to simplify ours for the ones that we work, and I'll kind of talk about that later on. But if we have a large thing to do, then we're going to want to do it as a system of linear equations. Okay, so let's get started and kind of talk about what review and then working backwards from there. Okay, so before we looked at stuff like if I wanted to combine these two rational expressions into one, I want to combine these two fractions into one. Okay, and how I would do that is that I needed to get the LCD. And then I would write this. The LCD for this case is just the x minus 1, x plus 2. So I'm going to turn everything in here to combine them over to, so I need an x plus 2 here, x plus 2, LCD is x minus 1, x plus 2. And then 3 over x plus 2, x minus 1, x minus 1. Okay. So now I would just multiply this out. So all of this now is over x minus 1, x plus 2, 2x plus 4 from here, and then plus 3x minus 3 over here. So now this would simplify into, I group everything, my 5x plus 1, and then over x minus 1, x plus 2. Okay. So that's the result of combining these and simplifying. As you go forth in your studies, you will run into something like this, and you need to simplify. Okay. So maybe this is not the simplest thing that you need to work with. Okay, in some cases, this is exactly what you need. In some cases, this is exactly what you need. Okay, but you would not have this basically given to you. You would want to do this, and this going back over to this is called partial fraction decomposition. Yeah, partial fraction decomposition. Okay, so what I want to do is start with this and kind of show you this technique in just a few minutes, but let's go back through, kind of hit some slides for a few minutes, and then I'm going to work backwards to go from here to here. And is there an easy way to do it? And it turns out there is a method to do this. Okay. So let's kind of get started on the size. So what I want to do for partial fraction decomposition, I'm looking at first a rational expression, some polynomial divided by a polynomial. So here my 5x plus 1 is a polynomial, and this would just be x squared. X squared plus 2x minus x is x squared plus x. So this possibly could be x squared minus x plus x minus 2. So I would have 5x plus 1 over x squared plus x minus 2, a polynomial over a polynomial. Okay. G of x is a product of linear factors. It may not be a product of linear factors. It may be, here's a quadratic or irreducible, and then we can go from here. Okay. So here's two things. G of x is a product of linear factors or irreducible quadratic factors. This we can go down into linear. Okay? So we need to try to factor it to start with. Okay, so set up a partial fraction decomposition. Okay, so here is the method. So if we went through these, we would work backwards. This is exactly what I did over here. It's just a different examples. So we've done this before, combine them, and they ended up with a 19x plus 29. Okay. Now they started with this, so I'm going to go through here. Here's another example, and then I'm going to use that one as well. Okay, so I'm going to change this out, And then I want to do a partial fraction decomposition of 5x plus 1, x squared plus x minus 2. Okay, so which is the x minus 1, x plus 2. The first thing I want to do is see if I can factor. Okay, so now I've got some room here to work with. Okay, so what I want to do is, I know here was something that I did. Here was kind of breaking it apart. I had linear factors and I put it together. So what I want to do is assume that I can break this thing apart and I have some version of A over this first factor and then a B over the second factor. Okay, so this looked like this and looked like this. And this is on this side. This is the very same thing, just a different form. Okay. Now what I want to do, once I broke this down, here's my factors. I want to find out, what is A and B? Okay. So what I'm going to do is just clear fractions. I'm going to get rid of these denominators on both sides. Right, x can't be equal to 1, x can't be equal to -2. Okay, make a little side note, but I'm going to multiply both sides by these factors. Okay, so here, x minus 1, x plus 2 times my 5x plus 1 over my x minus 1, x plus 2. Same thing here. And now this is times, I'm going to write this right down here, A over x minus 1 plus B over x plus 2. Okay. Now on this side, what we're doing is clearing fractions, so that goes out just like that on that side. So over here, I'm just left with a 5x plus 1. Well, what about here? So both of these are going to multiply times there, both of these times here. Okay, x minus 1 times x plus 2. When I multiply this times this, one of these factors is going out, right? Because I broke this down into that. So that goes out, so I'm left with the A, x plus 2 on that side, plus B. Now when I multiply all of this times this one, the x plus 2 goes out, right? And I'm just left with the B, x minus 1. Okay. So this is how I want to kind of work this thing. And then this is going to be a couple of different ways of handling A and B. There's equate like coefficients, a couple of different methods I could do. So if I expand this out, AX plus 2A plus BX minus B, and then I want to group these things together and factor out of X. So A plus B, X plus 2A minus B. Got to put these in parentheses because they go together. Here I just factored out the X. Okay. If I equate, so now I still need to find out what A and B is. I build a system of equations to do it. Okay. So this is equating like coefficients. This, the A plus B, that must be equal to 5. This has to be equal to 5x. And then here, without any x's, that has to be equal to the 1, the constant. Okay, so 2a minus b is equal to 1. Okay, which gives us our solution, our system of equations. And then what we want to do, if we look at this, we see a plus minus here. I'm just going to do addition, okay? Method of addition to get rid of that common factor. So here, a plus 2a, 3a, B's go to 0 is equal to 6, and now I can solve. That's just going to be my 2. So here, this is the A, the 2, that goes over the x minus 1. Notice that that was the 2 that's over the x minus 1. So we were able to get back. Now, how about the B? Well, once we got this, then I've got 2 from here. 2 plus B is equal to 5 minus 2 minus 2. So A is equal to 3, which is what we got here, okay? So what we would do at this point is rewrite this, is take this, my A is 2, so this would be equal to 2. My B is 3, I would rewrite that as a 3, and notice that's exactly what we got when we put these things together, okay? And again, in certain situations, this would be easier to deal with than that. Sometimes this is easier to deal with just writing it, you know, kind of graphing these things out, but handling them individually, you'll see that this is going to be better later on. Okay. So here I'm going to do the very same thing. Move this over a little bit. I want to decompose this. Okay. So 19x plus 29 all over x plus 6, 3x plus 1. And recall, we know what the answer is going to be. We worked it the other way. But what we want to do is once we get these into factors here, we've got this factor down here, I want to represent this as some constant over the first factor plus b over the second factor, okay? And then once we've got this, I just keep on, if I had several factors, I just keep doing this. And now I want to clear fractions. LCD is this, I multiply both sides by that, okay? So here, if I multiply both sides by here, I'm just going to have the 19x plus 29. Okay, and then on this side, my x plus 6, 3x plus 1, like that. Okay, so I've multiplied both sides over here. Both of these factors cancel, and then I'm left with this. Now this goes to here and there. So I distribute in both places. When I do this, when both of these go here, the x plus 6 is going to go out, and then I'm just going to be left with the 3x plus 1 times a, and then plus b, the x plus 6, 3x plus 1 goes out here, and then I'm just left with that times b. Okay? And this is my 19x plus 29. Let me slide this over for us. 19x plus 29. Okay. Now, before I multiplied this all out, got the coefficients and matched coefficients. So that was one way. Here is another way. I'm going to, this has to hold, this must hold for all x, okay? Because this was just an expression, it's not a particular x. It's like a function, you got to give me the x and then we can calculate. But it has to hold for all x, so we can choose, free to choose x. And if I have two of these things, what I'm going to do is basically choose 0 and 1. X equal to 0, write a system. Choose 1, write a system, and then solve that system. Okay, x is equal to 0 is always easy because there it just goes away. Okay, so 19 times 0. So for x equal to 0, I get 29 is equal to 3x is 0, so that's just a plus 6b. Okay, and then I choose x is equal to 1. And for x equal to 1, I get 19 plus 29, 4a plus 7b. And this is what? This is going to be our 18, 9 is 18, 2, 3, 4, 48. Okay, so 48 is equal to that. Okay. And then we solve this. Okay. So I notice this is just a multiple of here. Here's 4a times this. Let's multiply this times 4 and then do a subtraction. So this is the very same thing. If I go 4 times row 1, that's my new row 1. I clear this out, 29 times 4, 116 is equal to 4a plus 24b, and now this is 48 is equal to 4a plus 7b, and now I'm just going to subtract row 2 from row 1. Okay, so I'm going to do a subtraction here. 116 minus 48 I get 68 is equal to 4a minus 4a, that's 0a, and then 24 minus 7, that gives us our plus 17b. Okay, that's just out. There's nothing there. And then our b, divide both sides by 17, is equal to our 4. So now we know what our 4 is. What's our a? We just picked one. Let's go back to the easiest one to do. So let's go back here. 29 is equal to a plus 6 times 4. And that's 24. So 29 minus 24, subtract 24 from both sides. My 5 is equal to my a. Okay, so when we go back up here, this is 5, and our b is 4. And if we go back up here, there's our 5 over x plus 6. The a and the b must match. Once you've written this down, you have to go back and put it in the right place. There's our 5 over x plus 6, and our 4 over 3x plus 1. Okay, so let's move on from there. That's where we get from there. Simplified. So how do we set up the partial fraction decomposition? We have to make sure that the degree of the numerator is less than the degree of the denominator. We want to divide out if we don't. So we want something, the degree is smaller than the degree of the bottom. I'll be able to factor the bottom, the denominator, into either ax plus b linear factors or have an irreducible ax squared plus bx plus c. And remember what it means to be irreducible. These can be complex solutions to here. Okay, so I have no, if I graphed out that as a function, it's going to be above, it's either going to be something like this, or something like that. Down, I have no real solutions. It doesn't cut the x-axis here. So these are complex solutions. And that's called an irreducible quadratic. Okay. So linear factors, we have a couple of different types once we do this. I'll either have linear factors. So once I factor the denominator, I either end up with linear factors, just each individual type. So here would be like 2 over 2x minus 1, 2x plus 1, okay? So linear factors, they're distinct. And I would decompose this like this, okay? I could also have something like 2x minus 1, and let's go 2x plus 1 squared. Okay. For each one of these powers, I'm going to have to set up one of these things. So for 2, so I'll have a over 2x minus 1 plus b over the 2x plus 1 to the first power, and then I just keep counting up, plus c over 2x plus 1 squared. I'll just keep bringing these things up until I get to the same exponent as I got here. Okay. And then I could also have an irreducible. And if I have something like, and this would show up here, let's just go 2x minus 1, and I had some irreducible 3x squared plus 2x minus 1. Okay. I need something irreducible, so hopefully I get it here. And then I would have, so ax plus b over this irreducible to get it there. Okay, but I need a product here. Naturally, this would be the 2, and that would be the negative 1. But I would have a product here, and then this would be the next piece of it. Okay. So here was the one that we worked out a while ago. What about this? X times x was x squared times 2x. That would be an x cubed. The degree of this would be degree 3. And if we set this thing up, it would be, so it would look like a over x minus 1 plus b over x minus 5 plus c over 2x plus 5, clear fractions, and then start building our system of equations. Okay. So since we only did a system of 2 equations and 2 unknowns, we're not going to deal with those. Okay. So I'm just going to do the setup, and that would come up with a system of a 3 by 3 to get A, B, and C. I have 3 variables I need to solve for. That would be the 3. If I did this one, so I've got 10x squared minus 49x minus 86 over x minus 8x plus 1 squared, then I would have, this would be A over the first factor plus b over the first power of this, and then a c over the x plus 1 squared. I would have to count this up. 1 and then 2 to match the power over here. Okay. And again, multiply both sides, clear out these, and then this one, we would go through and set up a 3 by 3 to get those. We're free to choose what x's are. X equal to -1, 0, and 1. Once we get through, and then that would build up a system of 3 by 3. 3 equations, 3 unknowns. The unknowns would be the A, B, and the C. Okay, so let's do a couple of 2x2s as we go through. So minus x plus 18 over 3x plus 1 times x plus 4. Okay. Partial fraction decomposition. So I need an a over the first. It's already factored. A over the first factor plus b over the second, and that's my x plus 4. So once I get there, I want to multiply both sides by that very same thing, 3x plus 1, x plus 4, times this, 3x plus 1, x plus 4, times that. So this is going to go out, both of these factors times, so I'm just left with a minus x plus 18, just the denominator. I'm sorry, the numerator. And then here, this is going to multiply both of these. This one's going to cancel in this case because it gets here and here. 3x plus 1 goes out. I'm just got the x plus 4 times a. This times here, the x plus 4 goes out, and then I get a 3x plus 1 times my b. Okay. So here again, let's do x is equal to -1, 0, 1, just to build up that system. So for -1, this is -1, plus 1 plus 9 is my 19, 3a, so this is -1, so that's 3a. -3 plus 1 is minus 2b. For -1, this is -3 plus 1, -2b. Okay? I don't need this one. Let's just go. I don't need but those two. And then 0, 18, 4a, 0 plus b. I could have also done the 1 here, but that's all I need is just 2 of these things, okay? And now I see this factor, 2, so I'm going to multiply 2. This is row 1, row 2. Here's my 2. This is my system. 2 times row 2, that's my new row 2. So 19 is equal to 3a minus 2b. That's the same. And then this is times 2. 2 times 18, 36 is equal to 8a, 8a plus 2b. 2 on both sides. And now all I have to do is just add these 2, and that's going to cancel out. So 15. And then 5, 11a, and then this goes out to 0. So my a is going to be equal to 5. And then once I have this, I can pick either one of these. Let's go with this. 18 is equal to 4 times 5 plus b. This is 20. Subtract 20 from both sides, so minus 2 is equal to b. So this is going to be equal to the minus x plus 18. I match them up because this is the way I set these things up. So it's the 5 over the 3x plus 1. What's my b? My b is equal to -2. And now instead of writing a plus and a negative, This is the same thing if I just pull this out front as a negative there. Okay. So partial fraction decomposition for a 2x2 system, you would be expected to do. Okay, so a lot of these you can build up to a 3x3. You know, you'd have to extend these out, but since we only know how to handle 2x2s, we're just going to kind of reduce this section into only those things with 2 linear factors to be able to get them. Okay, let me show you one other thing though. I'm going to start with this again. This would cancel out, so I've got minus x plus 18 is equal to a times x plus 4. When I did this over, the 3x plus 1 cancels, plus b 3x plus 1. Okay. And again, you remember I said we're free to choose x. This has to hold for all x's. But what we need is the a and the b. Okay, so there's another way that we can do this thing, and it's just called the pick X, and I usually kind of do this in class as a pick X game. Okay, and what I'm going to do is choose to get which one that I would like to make this 0 to get rid of my A and then just solve for B. Choose this number to make B equal to 0, and then I just solve for A. Okay, so here I'm going to check for that equal to 0. So x is equal to -4. And then if I put here -4 plus 18. And this is what I'm writing in here. Here's my -4. Here's my 4 plus b. 3 times -4 plus 1. Okay. So once this goes, I pick that number to make that equal to 0, and now I just have an equation in B. So plus 4, 18, I've got 22 is equal to, this was my 3 times my -4, -12 plus 1 is my minus 11b. Yeah, this may be hard to read up here. So it is just my 3 times my -4, -12 plus 1 is -11. A times 0 is this, so that goes out. And my B is my 22 over -11. So that's just -2. Makes it easier to solve if I pick the correct value, okay? So my B, let me write this over here, B is equal to -2. Bring that back over. Okay, so I've got that. What I want to do is just do this over for my 3x plus 1 factor. I'm going to make this equal to 0, and that gets rid of this. Now this one turns out to be a little messy because of the fractions, but I'm just doing 3x plus 1 is equal to 0. -1 divided by 3, so my x is -1/3. And then I'm just going to put it in here. So 1/3 plus 18 is equal to, so here is, this one's going to go out to 0, and here's my a, -1/3 plus 4. Okay. So instead of doing all of these fractions, I'm going to clear fractions out again. So both sides by 3. And then this would just be 1 plus 3, 4, 5, 54. Distribute, -1 plus 12, the 3 goes out, and that just makes this look like A times 11. Divide both sides by 11, and then A is equal to 5. Which is what we got a while ago when we did this, but it's just a different method to go through and solve for A and B using nice values of X that first set this equal to 0, then sets that equal to 0, and then we can just solve for A and B. Okay, so that's the method of partial fraction decomposition. I wanted to look at one other thing, just sending it forward, so I'm going to go grab, this is from our text. So let me grab this just for a second. Slide this over. So if we go into our Chapter 8 material, here's our 8.3. There's a nice little table here that gives you the form of this. So here's with linear factors, and then some of these things may be repeated. So you would need separate ones all the way up for the power. So if you were just trying to decompose ax plus b to the m, each one of these you would need. Okay. And they use a little subscript. Here's A1. Instead of me doing like the A and the B, A sub 1, A sub 2, all the way out to that power. And then you would be basically solving a m by m set of equations. If you have a quadratic factors, then what we do, we'll do a bx1 plus c1, ba2x plus c2. But we need a combination of these things for these irreducibles. Okay, each one of these would be distinct. Okay. Okay. All right, we'll stop right there. Again, we're just focused on this time just 2x2 systems of equations, and all of our 2x2s basically look like A over something like this. Here's my first linear factor, here's my second linear factor, and I need a variable over each one of those linear factors. Okay. All right, so go through, look at some of those in the book. Get back with me if you have any questions, and we'll see you next time.